can of tennis balls has a 75% markup rate based on cost. Mel Sporting Goods sells a can of tennis balls for $3.49. What's the cost to the nearest cent? Okay, so they're asking us to solve for cost. Now, we don't have an explicit equation for cost, but we do have equations that involve cost. So use context clues to figure out what equation you might need. So they mention markup rate, so we're going to use the markup rate equation to indirectly get at cost. So markup rate is equal to markup divided by cost. Now markup, here's another one, markup is equal to selling price minus cost. Selling price minus cost. So you see that both of these equations involve the cost variable, and we need to use them, find a way to manipulate them to get us a solution for cost. Well, let's go ahead and just plug in what we know. That's always the next step, right? So what do we know? We know that our markup rate is 0.75 based on this, and we know that our selling price is $3.49. So where can we go from here? Well, we can use this equation for markup and substitute it in to our markup rate equation. If markup is equal to selling price minus cost, I can substitute these out and it's still an equivalent expression. Now the reason I'm doing that is that I know selling price. So this equation only involves cost. So notice that when I substitute this out, I get an equation that says 0.75 equals $3.49 minus cost, which is this part, divided by cost. Now I have this one variable equation, and the only variable left in it is the variable that I'm solving for. So again, I use substitution to set up an equation that has one variable in it, and the only variable in it is the variable that I'm trying to solve for at the end. So this is the hardest part of the problem, just recognizing that I can do that substitution. From here, it's a matter of solving. So I'll start by multiplying both sides by cost. This side it cancels out. This side gives me 0.75 cost. I'm just going to write C for cost to save space. So 0.75C equals 349 minus C. Okay, I'm going to add C to both sides. So what's 0.75C plus C? Well, remember, there's an invisible 1 there. So this becomes 1.75C equals 349. I divide both sides by 175. On this side it cancels out, and I find that cost equals $1.99. Now again, the major thing here was recognizing that I could use my markup equation and substitute in the equation for the term. The equation involved cost, which was the variable I was trying to solve for, which is why it made sense to do that. And I substituted it into an equation where every variable was solved for except the one I was trying to get at. Once I had my one variable equation, all I had to do was solve to find the value of cost. Let's do one more example. So this one's a little simpler. At the outdoor market, Craig Wang sells string beans for $1.99 a pound. The beans cost 89 cents a pound to grow. What's the markup rate based on cost? So this is an easier relationship. Once again, we're using that markup rate equation, right? Because they're asking us to calculate markup rate. Now, markup rate is equal to markup divided by cost. Now they tell us the beans cost 89 cents to grow. So there's cost, and they tell us the string beans are sold for $1.99. Now, markup is equal to the selling price minus the cost. So if they're selling for $1.99 but only cost 89 cents to grow, that means they're marking them up $1.10 each. So my markup is $1.10, and I'm going to divide that by my cost to find markup rate. So 110 divided by 89 cents is 1.236, or 123.6%. So again, to find this, I identified the variable they were wanting me to solve for, which was markup rate. I pulled out my markup rate equation. I plugged in what I knew. I had to solve for markup, and once I had that, I could solve for markup rate.